Hello, everyone. In this video, we will cover more examples related to the select and ultimate life tables. Let's take a look at the first example. Given a 2-year select and ultimate table, and the expected number of a group of individuals select at age 51 is 1,000, calculate the expected number of survivors for a group of individuals select at age 53. This example requires us to relate Lx and Lx plus k at two different select age. There's no direct way to link up these two quantities. We need to start from a select age, move beyond the select period, get into the ultimate part of the table, and then return back to the select period at another select age. That is, in this example, we start with L51, select at age 51. We have 1,000. We need to get L53. We start from L51, the select age at 51. We move along the table to the right, L51 plus 1, get into the ultimate part of the table, which is Lx plus 2, here L53. From that, move down L54, L55 until we reach the row corresponds to our destination. In this case, x equals 53. From this ultimate part of the table, get back to the select period. At select age 53, go left, and then we reach our destination here. All right, let's do the calculation. We need to get L51 plus 1, which is L51 times P51. We get 1,000 times 0.8. We have Q51, the select age at 51 is 0.2, so we get P51 is 0.8. L51 plus 1 is 800. And next, we compute L53. This is the ultimate part of the table. L53 is L51 plus 1 times P51 plus 1, which is 800 times 0.77. P51 plus 1 is 1 minus this value, 0.23. And we get L53 is 616. We are at the ultimate part of the table, and then we need to get L54 and then L55. And here we can skip L54, directly compute L55. L55 is L53 times 2P53. We get 616, and then times P53. We are at the ultimate part of the table. The value of the mortality probability is in this column. P53, we get Q53 equals 0.26. And then we get P53 is 0.74. And then for P54, we get Q54 is 0.27. So we get the corresponding value, 0.73. Upon calculation, we get L55. And then we can move to the left, get L53 plus 1, and then we can reach L53. We can do it in a single expression. L55, now we are at the select age 53, which is L53 times 2P53, select age at 53. We have the value for L55. And then P53, this is the select age. The corresponding value for Q is 0.22. We get P53 is 0.78. And then this quantity, 1 minus 0.25, we get 0.75. Upon calculation, we get the answer. 568.83. The next example. Given the same two-year select and ultimate table, and we are given that L53 select age equals 1,000, and calculate the expected number of survivors for a group of individuals at select age 50. A very similar question. We are now linking Lx and Lx minus k. That is, here we are given L53, 1,000. We need to get to L50. Similar procedures. Start with the select age 53, L53. Go to the right, move to the ultimate part of the table. Here we reach L55. And now we move upward to get L52. And then get back to the select period at select age 50. From L52, move to the left to get to our destination. All right, we get L55. So L55 is L53 times 2P53. The 53 is the select age. We need to get P53 and P53 plus 1, which is 0.78 and 0.75 respectively. Upon calculation, we get L55 is 585. Move upwards to get L52. We are at the ultimate part of the table. No more bracket. L55 equals L52 times 3P52. We need to get P52, P53, and P54 respectively. From the ultimate part of the table, we get the corresponding values. Upon calculation, we get L52, 1,443.91. In the table, we move to the left to get L50, the select age at 50. L52 equals L50 times 2P50, select age at 50. We need to get P50, which is 1 minus 0.19. And then P50 plus 1, 1 minus 0.22. And we get the answer. All right, let's move on to the next example. An example related to fractional ages. This example related to the UDD fractional age assumption. Given the two-year select and ultimate table, calculate 0.9Q60 plus 0.7. The select age is 60. Assume UDD. This quantity expressed as 1 minus 0.9P60 plus 0.7. And then we can express the P as L60 plus 1.6 over L60 plus 0.7. Make use of the interpolation formula. L60 plus 1.6, this is at age 61.6, which is between the two integral ages 61 and 62. And S is 0.6. Upon substitution, we get the numerator here. 0.4 times L60 plus 1 plus 0.6 times L62. Similarly, for the denominator, the H60 plus 0.7 is between the two integral ages 60 and 61. H60 and H61 are within the select period. So we have the square bracket 60. And this is a 2-year select period. Therefore, upon reaching age 62 and beyond, this is the ultimate part. Get the quantities. L60 plus 1, L62, L60. Upon calculation, we get 0.0109. The next example, another problem related to fractional age. In this example, we assume constant force of mortality. Calculate the quantity 1.7 Q60 plus 0.4 select age at 60. P60 plus 0.4 expressed in terms of the L's, which is L62.1 over L60 plus 0.4. Under the constant force of mortality fractional age assumption, we can get Lx plus S, where S is between 0 and 1, equals Lx raised to the power 1 minus S times Lx plus 1 raised to the power S. Therefore, L62.1, which is between the ages 62 and 63, with S equals 0.1. We get this expression, and then the denominator, the age is between 60 and 61. 2-year select period. At age 62 and beyond, the ultimate part. So we have L62, L63 without the square bracket, and the age 60 and 60 plus 1 here, we have the select age still within the select period. We get L62, L63, L bracket 60, and L bracket 60 plus 1. Upon substitution, and we get the answer 0.0209. That's it for today's video. Thank you for watching, and see you in the next video.